Hi, and welcome to Concept Based. I'm John Hepworth. This is the Year 11 advanced topic. We're in the probability and data section, and we're specifically in the data section. And this is looking at relative frequency. Now, relative frequency can be a bit of a weird concept because we just typically deal with frequencies. Like, if I'm rolling a dice, I would expect a 6 to appear 1 in 6 times. But if we go ahead and look at the real world, sometimes we can't predict what the actual theoretical probability of something's going to be. And we have to go and run a bunch of experiments and just collate our results. And we just assume that those results that we've collated is the appropriate frequency for the thing to occur. And obviously, the more of those experiments that you run, the more certain you can be about the relative frequency that you have come up with. So don't get tied down with the fact that it's a dice. It's got to have a 1 in 6 relative frequency for probability for all of the outcomes. It doesn't have to. Okay, we can go off experimental data, and that's what this question looks at. Additionally, I note I am using the word dice today, not the other word that we use to express one singular of the form, for a couple of reasons. One is I don't want the algorithm to get triggered by the fact that I'm saying that other word over and over. And secondly, colloquially, we use the word dice to express what one of them is. If some person was rolling one of them, we would still say, hey, roll the dice. But obviously, there's another word that we can use to express what just one of them would be. All right, so let's have a look at this question today. The relative frequency table describes the behavior of a dice. If the dice is rolled 60 times, how often would you expect to roll a 5? So the first step in this question when we look at this table is we need to realize that the 5's relative frequency is missing. With that relative frequency being missing, we have to use the other data to try and fill it in. And the question is well, how? How could we fill it in if we're not doing the experiment? We don't know how often a 5 comes up. Well, the reason is that you have to know that the sum of all the probabilities is equal to 1. Of course it is. The only outcome you could get is one of the outcomes of the dice. So if it's not the other ones, it has to be the 5 that we're looking for. So let's go and find out what the relative frequency total is of the others. 0.2 plus 0.1 plus 0 plus 0.3 plus 0.25. How do you do that in your head? Do you do it in order? I don't. I like to start with the big ones first. So 0.3 plus 0.25 is 0.55, plus 0.2 is 0.75, plus 0.1 is 0.85. So my probability of the 5 is all of the outcomes minus not my outcome. This is like a complementary event. So I'm going to minus 0.85 and I get 0.15. Okay, so now I've got my relative frequency of a 5. The question then says, if the dice is rolled 60 times, how often would you expect to roll a 5? Now we have to understand that we know that the relative frequencies are going to change as we roll it more because that's more information for the experiment, but we discount that. We're just going with the relative frequencies that we found in the table, and then for this prediction, we're just sticking with it. We're just assuming that the dice is going to roll in its exact continue relative frequency form to give us our answer. So all we really need to do is take our probability of 5 and roll it 60 times. So we just multiply it. So we do 60 lots, 60 rolls of 0.15. And 0.1 of 60 is obviously 6, a tenth of it. And half of that is 3, which we add on and we get 9, and we get 9 times. So we would expect that if we rolled this dice 60 times, we would get 9 5s. Now, obviously, this is a really good question in the HSC for a conceptual misunderstanding. Speaking about being a concept based here, because students may just read the words, not look at the table and go, oh, a 5 is 1 in 6. If I roll it 60 times, I'll get it 10 of them. And they'll just put 10 down, just assuming that that's correct. Not at all. You have to use the relative frequencies because this is an unfair dice. I mean, look how often a 3 came up. It didn't at all. So it's definitely not evenly weighted, this dice. So we have to use those relative frequencies and not write 10. This could even be a really good multiple choice question where one of the incorrect answers is 10 that a student might just immediately pick. So just be aware when you've got a relative frequency that's given to you, and that's what you're going to have to calculate off, make sure you're using that, not the assumption of what you expect the frequency to